Hello, in this video we're going to be factoring using a method called grouping. Now, I have two different polynomials here, and when we factor, I'll remind you, we want to look to see what multiplies together to make these polynomials. Now, each of them have four terms, both 1 and 2 have four terms to them, and that are the only type of polynomials that we are allowed to use grouping on. They have to have four terms. Now, anytime we factor, again, we're looking for what multiplies together to make these polynomials. We start by looking for our greatest common factor. Is there a number or letter or combination of those that multiplies in or divides out of all of the terms? And the answer here is just a 1. Now, 1 doesn't change anything. However, these are not actually prime. We can factor them. So, let's go ahead and do that. When we do grouping, we're going to group together the first two terms and the last two terms. From here, we look for the GCF of each of those groups. So x squared minus 3x has a GCF of x. And when we divide an x out from both x squared and minus 3x, we're left with x minus 3. Plus, from 4x and negative 12, they have a 4 in common. And when I divide that out from both things, that leaves us with x minus 3. Now, in this, our x minus 3's are now in common. So take a look. Let's consider that one term and this one term. So of those two terms, they have an x minus 3 in common. So we'll write the x minus 3 out front times, and then what's left? If I divide this by x minus 3 and divide this by x minus 3, well, that's going to cancel and that's going to cancel, and we're left with just x plus 4, close parentheses. And that's the factored version of this. We can check our answer by doing the FOIL process to see if this goes back to where it was. X times x makes x squared. X times 4 makes 4x. Negative 3 times x makes minus 3x. Negative 3 times 4 makes minus 12. And while these in the original are switched, it was a minus 3x and then a plus 4, that's okay. We can change the order that we do addition by the commutative property. So that is indeed the same as what we started with. Let's try number 2. And I'm going to rewrite number 2 to make it a little easier to see for us what we're going to group together. So x cubed plus 5x squared. Then I'm going to do a plus negative 6x minus 30. Because our first two terms are x squared plus 5x squared. Our last two terms are the negative 6x and the negative 30. Okay, we can add the negative 6x, but then we group that negative with the 6. All right, we look for the GCF of each group. What divides into both x cubed and 5x squared is an x squared. And when we divide that out, we're left with x plus 5. What divides into both negative 6x and negative 30? And the answer to that is a negative 6. Negative 6 divided into negative 6x is a positive x. Negative 30 divided by negative 6 is plus 5. Then finally, what's in common with both terms? Again, so we have two terms, there they are, and they have an x plus 5 in common. And that leaves us with x squared from the first when we take that away, and the minus 6 from the last when we take the x plus 5 away again. And we can once again check by doing our FOIL process, x times x squared, x times negative 6, 5 times x squared, and 5 times negative 6. And so again, you can see how we can flip these around using our descending order, and it would look exactly like the original. So this is indeed the factored form of number 2. Okay, so that's how we factor by grouping. For now, we are done.